Welcome to Networks Professionals.
Welcome to the Explainer. Okay, if you manage a network, you already know the deal. Letting every single packet of data just free flow across your boundaries? Yeah, that's a recipe for absolute disaster. We absolutely need control. We need a gatekeeper. So today, we're demystifying access control lists, or ACLs. And we're going to do it by framing your network security through a pretty fun, highly visual metaphor, the digital bouncer. So grab your metal clipboard, because we are about to lock down the perimeter. All right, picture this. You've got a high-end, super exclusive nightclub. Outside, absolute chaos. Just unmanaged traffic, anyone and everyone trying to push their way through the front door. Now, a network interface without rules is basically that club with no front door. It is literally just asking for trouble. But now, imagine a digital bouncer standing right there at the network boundary. And hey, this isn't just any bouncer. This is a highly meticulous, totally unforgiving gatekeeper. This bouncer treats your network interface like a true VIP entrance. Only approved, specifically requested traffic is actually allowed inside. Everyone else, sent packing. And honestly, that's the exact mindset we need when thinking about how we filter network traffic. Okay, let's dive right into this and translate that bouncer metaphor into our actual technical reality. An access control list, or an ACL, is basically a set of security rules applied directly to your network devices. We're talking routers, switches, firewalls, the whole shebang. These rules give your device the power to explicitly permit or deny specific packets from crossing that boundary. And we're not talking about vague suggestions here. It's about absolute, binary decisions. You are programming that digital bouncer with a super strict set of criteria, telling your hardware exactly who gets the VIP treatment and, well, who gets tossed to the curb. So how does this gatekeeper actually do its job? Well, when a packet hits your router's interface, the ACL uses a really ruthless sequential logic. First up, top-down checking. It reads the rules one by one, starting from the very top of your list. Then, the instant a match is found, the millisecond a packet's information matches a rule, boom, the permit or deny decision is instantly applied. And finally, stop. No further rules are checked at all. Because of this sequential logic, the order in which you write your rules is literally everything. Think about it. If you accidentally drop a deny all rule right at the top of your list, that bouncer is going to reject every single packet, even if there's a VIP permit rule sitting just one line below it. Now this brings us to a massive networking gotcha, one that catches out even seasoned professionals all the time. It's called implicit deny all. So the crucial point is that every single ACL concludes with an invisible automatic rule that drops any traffic that hasn't already matched an earlier permit rule. If a packet survives all your top-down checks and doesn't match a single line, it doesn't get a polite little rejection. No, it gets deleted, dropped, tossed into the digital alleyway without a second thought. The bouncer defaults to no. If a packet isn't explicitly on the list, it's out. Keeping this invisible, totally unforgiving rule in mind, I promise, it's going to save you hours of pulling your hair out when perfectly good traffic suddenly just disappears. To actually manage all this strict filtering, you've got two main tools in your toolkit: standard ACLs and extended ACLs. Think of standard ACLs as your basic entry-level bouncer. They filter traffic based solely on the source IP address. Basically, they just check the ID to see where the packet came from, and that's it. Super simple. But sometimes you really need more detail, right? That's where extended ACLs come in. This is your advanced, highly granular bouncer. Extended ACLs don't just check the source IP. They check the destination IP, the protocols being used, like TCP or UDP, and even the specific port numbers. So say you want to block a specific employee's PC from hitting an HTTP web server on port 80, but you still want to let them send emails, an extended ACL gives you the exact precision you need to make that happen. Now, what's really interesting about this next part is the technical toolkit you need to actually build these rules into your devices. The syntax can look, well, a little weird at first glance. Instead of your standard subnet masks, ACLs use wildcard masks to define the range of IP addresses that a rule applies to. You can kind of think of them as the inverse of a normal subnet mask. So take a mask like 0.0.0.255. In a wildcard mask, the zeros mean this must match exactly, and the 255 implies that the entire last octet is totally variable. It's basically a clever, quick way to encompass an entire subnet of devices in just one line of code. And the second core component you need to know is direction. You can't just write an ACL and call it a day. You actually have to apply it to a specific router interface as either inbound, checking packets as they arrive, or outbound, checking packets as they leave. Because an ACL without a direction is essentially a bouncer standing out in the parking lot instead of guarding the front door. Of course, getting the theory down is just step one. To truly master this, we've got to get our hands dirty with some real-world application. As you're planning out your own implementation, I highly recommend diving into some practical setup resources. For instance, the Fortinet Network ACL guide is fantastic. It gives you these incredible, comprehensive overviews of the concepts in action. Or if you're looking for step-by-step configurations where you can actually see the command line syntax laid out perfectly, places like networkacademy.io are just invaluable. Drafting these exact commands absolutely requires practice, and resources like these will walk you through the exact keystrokes you need to build your own digital gatekeeper.
So what does this all mean for you? Well, it brings us to the final and really the absolutely crucial question for you to take away today. What device or cloud platform are you actually configuring right now? Are you working in a traditional Cisco IOS environment, or maybe securing virtual networks up in AWS or Azure? And even more importantly, what's your specific goal here? Are you just trying to block a single malicious IP address from hitting your web servers? Or are you building a highly granular system to restrict internal employee access to sensitive databases? Remember, your environment completely dictates your rules. So before you type out a single line of code, ask yourself, who actually makes the cut for your VIP list, and who gets left out in the cold?
Thanks for watching.